People did for a while think that Mars wasn't a desert, did they? Back in the 1600s and stuff.
Yeah.
They thought that there was like was it not 1600s? Obviously later than that. When the Schiaparelli stuff's like 19th century.
No, I think it was before. I think it was earlier than that. Yeah, I think it was 17th century, 18th century. Okay. Yeah.
Yeah. Anyway, but they thought there were canals and things on Mars.
Yeah.
And for a while before we
like
really
civilizations like building huge canal systems.
Yeah.
They were essentially just an optical illusion.
Yeah.
Something to do with like looking at the thing through a crap telescope, basically.
Yeah. And the way it was kind of the surface is coloured.
Yeah.
Gave that suggestion.
Yeah. People were talking about rainforest or like patches of vegetation and oceans and stuff that they thought they'd seen.
I mean, I think at one point it was commonly thought that there was like a civilization on Mars, like a Martian.
Yeah.
Or it wasn't not an uncommon thing for people to think that.
Yeah.
I mean, you still get the odd person who thinks it now. There isn't.
No.
And that view changed when Mariner got there.
Yes.
Mariner
4, which was in the 60s, I believe. 63, I think. Something like that.
And that just sort of looked at it and went, oh, it looks like a crater. Basically, they saw loads of craters on the surface, which is like a bad sign when you're thinking of planets, because if you have life there, you're not going to see craters. Everything's going to be, if you have tectonics and other things.
Water as well.
These are going to be, you're going to lose the craters.
It made it look more, like the moon.
It made it look like the moon.
Just like the fact that you have a shitload of craters basically just means that
there's not much
the surface is just still and nothing happening for like billions of years for all these craters to accumulate.
Yes.
So it was a bit like,
a bit of a downer.
After all of that time of like being like, there's all these civilizations and forests and oceans, and then you get there and it's like, it's basically just the red moon, and that's it.
Yeah, and that put a bit of a spanner in the works. But it wasn't until later when there was another Mariner.
Yeah, it was. It was about 10 years later, I think. There's another Mariner. So the Mariners were like flybys, or I think maybe this actually Mariner 9 was it was Mariner 9 in the 70s. It went into orbit around Mars. So I think
it was the first thing to orbit another planet.
Yes, because the original ones were just flybys and just taking a few pictures. Oh shit, there's some craters. That's it. And then Mariner 9 went into orbit around Mars and started taking tons and tons of images. And like suddenly people started realizing, hang on a minute. Yes, there's loads of craters. There's also tons of other stuff. Really interesting stuff.
Very interesting stuff.
Lots and lots of evidence of water.
Yes, lots of the sort of things you would see in river networks on Earth.
Yeah.
Like traces of valley networks and larger flow channels, all sorts of things.
Yeah.
Which I imagine at the time when those people got those photos back from Mariner 9 must have been like, what the hell?
Yeah, it would have been nuts.
Yeah.
Especially after that period of time of thinking like it was just a dead planet, and then suddenly you're just looking at these images like, fresh from the spacecraft, and you're just the first. Imagine being the first person or first group of people to look at it. It's like, but Jesus.
Those like geomorphological kind of features are not a guarantee that they were formed by water.
That's true, yeah.
People had speculated for a long time that they might. I mean, we'll go into this in more detail, but like CO2 or lava or things might be related to them. So
yes, but I mean, as you said, we'll go through it. But the evidence is stacked up now, so that we know that most of these features are water formed.
Yes, it has.
And there's lots of them. I mean, certain age terrain on Mars is just covered in this stuff. Yes. And like people talk about lakes and river systems and even like potentially oceans and that kind of stuff.
Yeah.
So, it gets nuts.
Yeah, and so I think it's probably worth. We're trying. So basically, we're saying that at one point Mars was kind of a habitable environment. Maybe.
I mean, it looks like it, right? If we accept that this is water.
If we accept that that's water, then if there's liquid water flowing on the surface of Mars, then maybe it was a habitable environment.
Yeah.
So if you think about the geological history of Mars, so you kind of need to understand when this was happening on Mars and a bit of the geological history to sort of understand how old this stuff is, and when it would have been happening and why Mars looks so different now. So the geology of Mars is typically split into three big eons: the Noachian, the Hesperian, and the Amazonian. The Noachian being the oldest, which is like 4.5 to
it's basically
3.7 or something billion years ago. It's absolutely ages ago.
Yeah,
I can't remember exactly.
Yeah, I think that's right. I think it's like 4.5 to 3.7.
I think it changes as well a bit.
Yeah, but that's billions of years.
Yeah, so it's absolutely.
So it's like just after the formation of the solar system, essentially.
Yes.
Up until about 3.7 billion years ago.
Yeah. The Hesperian afterwards goes to like from the end of Noachian to I think it's like 1.8 or something.
No, it's
3.
It's about 3. Yeah.
3.
So Hesperian's shorter.
3, yeah.
It's about 1 billion years or something like that.
Yeah.
And then from the rest of it is just this period of time called the Amazonian, which is just like where it's been sort of like this, like the way it is now.
Yes, it's just been the kind of cold desert.
Yeah, with bits and pieces happening.
Because some of the Hesperian features still kind of appear in the Amazonian, the early Amazonian.
I mean, this is again like it's a whole planet.
Yeah.
Like the Earth in a way. So like imagine trying to split up the geological history of the Earth into 3 sections.
Yes, exactly.
You know,
I mean, the Earth's a lot more active than...
It is a lot more active, yeah. But the fact that we just don't know much about Mars. We just don't know that much about it.
No.
So it's very like broad brush sort of.
Absolutely. And people do divide it in different ways.
Yeah, there are different.
There are different divisions based on some geochemical parameters and other things.
Yeah.
But yeah, we just use that Noachian, Hesperian, Amazonian.
Yeah. So that's the thing. So they're actually useful. Those periods are useful to talk about in terms of water, because of when you look at the surface of Mars, a lot of these like massive valleys and networks being carved out, and like where all the tons and tons of water was like just flowing around on the surface was in the Noachian, which is
or in the Hesperian. So in these earlier periods.
In these earlier periods, yeah.
So if we think about the Noachian would have been the point in time when the Earth was what age was it? It was like, well, it's like the Hadean or something. Like it was on Earth. Life either was just appearing or just appeared, and at the same time on Mars we have a habitable environment. So the Noachian was, like I said, finished about 3.7 billion years ago, I think. I can't remember exactly.
I think that's right.
And at this time, it's the Noachian environments are the things that Curiosity is looking at.
Yeah, the Curiosity rover, in Gale Crater. Yeah.
Yeah.
Oh, well, actually, that's not entirely true.
Well, no, it's not.
Hesperian
but it has been looking, hasn't it?
They are Hesperian in age.
But it's the early stuff.
But they're class. Yeah, they're all Hesperian in age.
Is it?
Yeah. So this is a perfect example of how all these things sort of overlap, and like the really clear divisions between like the 3 eras
sort of
aren't really. There's lots of overlap, but it is. I mean, what it's looking at is super old.
Yeah.
Like 3.5 or 3.6 billion years old.
Okay, so it's right on the edge of the boundary.
Yeah.
Anyway, so in that period of time, we see lots more the formation of very fine like valley networks.
Yeah.
I mean, people have even hypothesized that these valley networks, they're still there on the surface of Mars because there's so little turnover on the surface of Mars that they haven't been destroyed by tectonics, which you would get on Earth.
Yeah.
Or by like biology or
volcanoes
water or volcanoes, exactly. But they're so fine, so kind of detailed in places that people have hypothesized that they're formed by rainwater.
Yeah.
Like literally rain. These are rain formed, like dendritic basins.
Yeah, full on hydrological cycle.
Yes.
I mean,
in early Mars.
Yeah, and what you talk, it's just Earth. Like early Mars, and early Earth were probably very similar.
Yeah.
Because they were both newly formed planets. They both had very hot, active like cores that hadn't lost the heat of formation. Mars probably had a magnetic field at that time. Probably lots of rudimentary tectonic activity maybe going on, lots of volcanism, lots of water. Both planets, Mars was just like a slightly smaller version of Earth.
Yeah.
And that's the mad thing, is that Earth, we know at that time, Earth had life.
Was becoming habitable, or
becoming inhabited.
Was becoming inhabited.
Yeah, at the time that Mars was also like that.
Yeah, which is a crazy thing. It's solar system of 2 habitable planets.
And the other thing it implies, like the fact that you see all this evidence. I mean, as you're talking about Curiosity, the environment that Curiosity rover is driving around in, like, I don't know if anyone saw these pictures from like last year or the year before, these like layers. The first set of pictures they released with these like layers of sediments, just stacked on top of each other.
Yeah. Absolutely, like classic lake sediment deposits. Yeah,
and that implies that lake that is now obviously gone, but that lake that is driving around, the lake was there for like tens of millions of years.
Yeah. And the water there was, neutral pH. In fact, one of the lead scientists said Grotzinger said you could have drunk the water had you been there.
Just drink it, yeah.
It's that benign an environment.
Yeah. It's just a lake. It's just a lake. It's literally, you just go to like...
Just a lake, yeah.
It's just standard, like, legit lake.
Like, barely saline. I don't think it was particularly...
No.
Saline, just a sort of neutral kind of lake. Just a nice watery lake.
Yeah. And have a swim.
Down, have a fish.
Yeah, well, all those little Martian fish swimming around.
But there's not just evidence from the rock record. in terms of geomorphological features, so these valley networks, and these other types of deposits, we see clays in there and lots of other minerals like gypsums and other things, and jarosites later, but that can only be formed in the presence of water.
Yeah, basically.
And so you've got this like ground truthing data from the rovers that basically turned the debate between the people who thought maybe there were CO2 channels or like liquid CO2 on the surface of Mars in ancient Mars, forming these channels, or lava or anything like that. That it kind of just put that to bed when everyone was just finding like tons of water-formed minerals that can only form in the presence of water all over the surface. Yeah. It's like, oh well, that's the end of that debate.
It's like wherever you find these like networks of like valleys and like deltas and stuff like that, they're just covered in minerals that only form in water. Yeah. So it's like, well. Yeah, definitely water.
Yes,
definitely lots of it. And the other thing that implies is that way back at that time, Mars must have had a much thicker atmosphere, because at this point, like right now, liquid water, like pure liquid water, is just not stable on the surface. It'll just boil away, evaporate straight away or freeze. So the fact that you had like lakes and rivers and stuff like that means that there must have been more atmospheric pressure, probably like CO2, like lots of CO2, so it's like a greenhouse gas, raise the temperature. So again, and people have calculated this, and it ends up being that you basically need an atmosphere that was in a very similar pressure to Earth's atmosphere to explain what you see on Mars. Yes. So again, it's another like line of evidence that
and for a while it was kind of a mystery as to how Mars lost this atmosphere, and I think we know a lot more about it thanks to the MAVEN mission.
Yes.
But the fact that you can see the lake sediments, and the fact that you know that they are in these neutral conditions, you have all that evidence on the ground to say that the atmosphere had to be thicker. So you have to work back from that point. You have to assume the atmosphere was that way, and then explain like how it lost it, rather than sort of saying like there's no good evidence to suggest otherwise.
Yeah, there was a bit of an argument going on between people who said that these valley networks have all been formed by like a hydrological cycle like you see on Earth, which implies like high temperatures and a thick atmosphere. And there was another school of people who said it can all be explained by quick like pulses of water driven by like local volcano activity or asteroid impacts.
So something melting some of the ice.
Exactly.
That sort of stuff.
But then Curiosity landed, and there's obviously other missions like MAVEN have helped with this, but Curiosity landed in a place where we can see that a lake's been sat there for like 10 million years or whatever. So it's like
painfully obvious. You stick a geologist in that environment on Earth and they're just like, it's just a lake sediments. And it just it's just so obviously lake sediments.
So that's like, that puts that to bed basically, in the sense that obviously there's been standing bodies of water for a long time. It's not just like a pulse of water that's happened quickly.
I mean, if normally when you get lake sediments like that on Mars that are very finely laminated, very fine grained, you don't. If you have a big kind of inundation of water, you don't get that type of deposit. It's much more mixed up. Or you get much larger chunks mixed in there.
That makes sense.
And they do see that. They see. In the channel networks running up to the place that Curiosity found these lake sediments are these like conglomerate rocks that are basically like almost like river sediments, like higher energy kind of deposits, feeding down into this lake. And the fact that you get this very fine laminated stratigraphy that don't worry about that word, just different layers of rock, that essentially you have something that to form something that thick, the deposits they're seeing is it takes millions of years or thousands. Well, I can't remember the actual numbers they tried to put on it, but it takes a very long time. That body of water was standing there for a very long period of time.
I'm pretty sure
deposit that thicker layer.
I'm pretty sure that the like some of the mission PIs have used the word tens of millions of years. I could be wrong.
I can't remember exactly.
But I do feel like I've seen that.
It's a significant period of time. A very significant period of geological time, enough to stick down a fat deposit.
Yes. So that's the really ancient Noachian stuff. But even as you move further forward in time, like you didn't get so much of these standing bodies of water that were around for a long time. You did get like big events, like single, like powerful.
So as you move into the Hesperian, and obviously on the edge of the Hesperian, as Mark was saying, the Curiosity is in the edge of the sort of Hesperian Noachian. As you come into the Hesperian, that those types of environments seem to maybe not die off, but they become much more kind of catastrophic, much more volcanically kind of dependent and driven, and the atmosphere is probably starting to be lost at that point. A little bit.
So like most of the water is probably frozen like most of the water that was just in the lakes and rivers is probably frozen or underground, and then you have these like events, these like cataclysmically large flood events
that bust out,
which are insane.
You have like a huge like hydraulic head of water that's built up over a long period of time, and you get a volcanic eruption or something that cracks through the cryosphere, the ice, and then you get this enormous flood, like biblical flood, much bigger.
It's happened on Earth. I mean, there's a place in North America called the Scablands where.
In Washington State, isn't it?
Yeah, I think so. Where like that looks like it's happened, and like
it was a glacial outburst flood.
Yeah, it was like an ice dammed lake, basically. Then the ice broke, and then all the water came through.
Like a Yokup or whatever they are in Iceland, a little bit like those.
Yes, obviously they are that, but they're a bit smaller.
Yeah,
a lot smaller.
Because
this one was like literally. The volume of all the world's rivers like ran through it in a period of like 3 days or something stupid like that. It's unbelievable. Yeah. And like the landscape is just like giant canyons that were all just scoured out in like a matter of
very short
days
periods
or weeks
of time,
or whatever.
Or multiple.
Yeah, probably maybe bursts.
But they scour out a huge area of land very quickly.
And you see these on Mars, and they're different from the valleys, because the valleys are all these kind of like branching like river systems.
Yeah, they're very complicated. I mean, you see
deltas and stuff.
Yeah, you see.
Whereas these are just like just ploughed through the landscape.
Yeah. They tend to be very shallow depth. But very wide.
Yeah.
The width to depth ratio is different to the valley networks, which are much more like V-shaped, like typical long-term flow features, rather than the big like scour features that come out.
Yeah.
The outflow channels are absolutely spectacular. If you look at satellite photos of Mars, you can see them at the end of Valles Marineris and stuff. They are unbelievably huge, some of them.
Yeah.
And we'll probably do a video.
Yeah, I think we probably will.
Doing like a tour of Mars or something.
To point out some of these things.
Yeah, where you should
just
look
so worth checking out.
Yeah, they are. Yeah.
Especially when you know
a sense of scale and stuff.
Yeah, when you know a sense of scale. That's the thing. Is like obviously looking at a map of Mars, like it's hard to get a sense of scale. But like some of these things are just unbelievable. When you do have like a reference point, and you can just Google something. You know, people have superimposed like a map of like the United States on top of Valles Marineris, for example, and it's basically the width of the US.
Yes.
So like an outflow flood coming out of one side of it is like the size of Florida or something.
Yeah.
Just
a channel the size of Florida.
Yeah.
This is crazy.
It's just scale like so much bigger than anything we have on this planet.
Yeah. Yeah.
Yeah.
As far as we know.
Yeah.
The planet gets covered up here.
Yeah.
So that in the Hesperian time, you had these much more kind of surface volcanism that was kind of cracking out. You end up getting these big outflow events and lots of volcanism. Earlier on in Mars's history, presumably there was a lot of volcanism to get the atmosphere thick, but the Noachian doesn't have all the same like sulfur deposits and all that sort of stuff.
No, it doesn't. It doesn't. No, and I'm not sure. I don't know that much about like volcanism history over Mars, but presumably it would have been pretty active like way back in the Noachian as well, just because it was a fresh planet, it's a young planet.
Yeah, exactly. Yeah, the heat flow's massive.
Just going crazy.
Mars doesn't have a normal kind of heat flow system compared to the Earth. So the Earth has, you know, like these subduction zones and upwellings and mid-ocean ridges, where the heat gets released in that way. Mars seems to have this like giant blister that seems to have come out of the lithosphere, and just all of that heat released is like in that one area almost.
The lithosphere is just like the rock.
Just
like exterior.
I mean, don't worry. Yeah, don't worry too much.
Sam's just got his geologist hat on.
But don't worry too much about that. It's just the fact that everything seems to have come up in like more or less most of it come up in one enormous plume.
Yeah.
Yeah. That's
where all the massive volcanoes are all like associated with this huge like bulge coming out of the side of the planet.
Yeah, it's like lopsided.
And people reckon, and it's probably true, that the activity of that bulge is sort of driven like almost everything on the surface evolution of Mars. So like these three eras and what's happened to like the water and everything over time can be almost entirely explained by the activity of this giant bulge.
Yeah, and there are volcanoes, the other ones that pop up in certain areas of the like northern lowlands that aren't part of Tharsis. They're just like little heat release, like hotspot type things.
Yeah, sure.
But the majority of it is concentrated in one massive area, and it's not like that on Earth.
Yeah, and that massive area is called Tharsis.
Yeah,
which
bad
is
ass.
An amazing name. So like all the volcanism that's happening during the Hesperian time was having like a big effect on actually like the water chemistry itself. So it was starting to concentrate stuff like sulfur dioxide and things in the atmosphere, which was reacting with the water. And essentially, I mean, we know before we were talking about these like standing bodies of liquid water that you could like drink from the Noachian and from Gale Crater and stuff. Yeah, I mean, it starts to get to the point where you probably wouldn't want to drink this water.
No.
It starts to get a bit nastier, a bit more acidic, and what we start to see is water related minerals that are laid down from that time are a different type of mineral, and they're sulfate minerals, and it's basically just evidence that the water was a bit horrible.
Yeah, and big like thick deposits.
Yeah, big thick deposits. Yeah, so if there was like standing water for a start in this time, because the atmosphere was starting to cool down and the planet was, liquid water wouldn't have stayed on the surface for so long.
No,
things evaporate and dry down. You get very salty, very horrible like water, and the evidence for that is
every time you get a new outflow of water as well, that soaks up and dissolves all those salts.
Yeah.
So you get this like horrible, briny, more acidic. Yeah. And as the Hesperian went on, that got worse and worse.
Yeah. So
the start of the Hesperian, though, like we were saying in the Curiosity thing, is sort of, there's still like neutral environment.
Yeah, it seems to be like large.
But as the Hesperian went on, that died off.
Yeah, and you just end up getting these huge like outflow floods we were talking about, and then any standing water was not very nice.
Becoming worse.
Yeah. But then so some people talk about, in fact, quite a lot of people talk about the existence maybe of a large ocean in the northern hemisphere of Mars.
Yeah.
And like periodically throughout the Noachian and Hesperian. So in the Noachian, it might have even been like massive, like a full on like big old ocean.
Well, it's worse. Have we talked about the dichotomy? We haven't, have we?
No.
So the Mars is kind of weird. The planet is split into two halves roughly, seemingly based on its like geomorphology, surface geomorphology. Yeah. One half is very, they call it the Southern Highlands and the Northern Lowlands, and there's a very clear like topographic divide between the two.
Yeah, it's almost just around the equator, like very roughly.
It kind of goes all the way. Yeah, like Tharsis is kind of like kind of makes that line kind of dodgy and whatnot. But there's certainly a very different sort of topographic. There's a very different change.
Yeah, like the southern land.
It's very flat and.
So the south is all like big mountains and like crazy like high elevation stuff and like chaos terrain, which is all just like mangled like crazy terrain.
It's much more rocky and
but
the northern lowlands are much flatter and
just like big expansive plains.
Yeah,
and a lot of people think
where Phoenix landed on the northern lowlands.
Yeah. And so that's the thing, is a lot of these outflow channels and valley networks actually lead towards
into the northern,
which is unsurprising.
From the southern highlands down into the northern lowlands. Yeah. And that's led to people to hypothesize that there was an ocean once in that northern lowland flat area. Yeah. But there is the actual existence of the northern lowlands is probably not related to that. It probably exists before the ocean existed.
Yeah, it might have been.
So it might have been a huge impact crater or some weird planetary formation type thing that was going on with the
again, it might be related to
crustal development. It might be related to Tharsis. Maybe. We don't really know what it is yet, but so there might have been an ocean.
There might have been a big ocean, and so people think that it could have been like waxed and waned, like so it could have been like a big ocean in the Noachian, which as the planet started to cool down and lose some of its atmosphere, a lot of the water either froze or evaporated, and then like big outflow floods during the Hesperian would have like recharged that ocean. Yeah. So there might have been like periods where there was very little ocean and then like kind of more of ocean again, and then up and down.
Dried right down potentially, and so that you get these pulses potentially of like ocean existence on and it would have been larger and more consistent in the Noachian, and getting probably smaller and periods of it not really existing as you go further into Mars's history, and to the point I think the last one is thought to be roughly in the divide between the Amazonian and the Hesperian, and that would have probably been a pretty like horrible kind of,
it wouldn't have been very nice
probably
around that time.
Bit of a gammy ocean.
Not very nice. And that was about 3 billion years ago. There's the boundary between the Amazonian and Hesperian.
Yes,
so it's still like a long time. And the Amazonian, which is the third sort of very broadly speaking era of Mars' geological evolution, is from then on, basically. So the last 3 billion years.
I think 3 billion years. The dinosaurs died out like 65 million years ago. Yeah. This is 3 billion. So it's a long time ago. Yeah.
So so most of the really interesting stuff that's happened with water happened before then. There were things going on throughout the Amazonian, and
like pulses of volcanism,
and there are some younger like outflow channels from the Amazonian. So there obviously were like more like catastrophic floods happening during that time.
But it died off. It
died
slowly.
Slowly died off. Probably again all tied to like the gradual slowing down of Tharsis. Like volcanism's not so happening so much. So
the
planet's
planet's
not so much
just
energy.
cooling.
Yeah, the planet's cooled.
The radioactive decay, everything that so like planets, there are various things that power the inside of planets that generate heat. Like tidal heating from the deformation of like large bodies. You get that on places like Europa. That's not really a problem on Mars because it doesn't have a big tidal body.
Yeah, there's nothing
messing with it. And on Mars, it's like radioactive decay of isotopes. So everything's degrading down over time, and that heat source dies off as everything becomes its daughter elements, and it just naturally radioactively decays, and there's less heat produced from that. So those types of inputs slow down as time goes on, and because Mars lost its dynamo, it couldn't retain that atmosphere. So you lose the volcanism, you lose the input, and you've lost your dynamo, and it's just all it's doing. You don't have a magnetic
field. Radiating heat
it's losing heat to
atmosphere
to space, and the atmosphere is getting knocked off by particles coming in from the sun.
Yeah. Which is what Maven is.
Yeah, Maven
has sort of finally now put some like actual numbers on that.
Yeah, and so during the Amazonian, that 3 billion year period of time, that got worse and worse until we got to the present day.
Yeah.
When Mars is kind of rubbish.
Yeah, it's just like a freezing radiation-soaked desert now.
Yeah, with a very, very thin atmosphere.
Yeah.
Almost exclusive. It's just mostly carbon dioxide.
Yeah, about 1% the pressure of here.
Yeah, so it's super low. And Maven literally was measuring things like during solar storms there was much more hydrogen coming off the atmosphere, and you can see these maps of carbon and hydrogen and nitrogen or whatever escaping from the Martian atmosphere.
Yeah. But there are, so through the Amazonian there were and still are processes happening, some of which are pretty damn interesting, and we will talk more about that next week.
Yeah, so it's not that. Well, we'll talk about it next week, because we're going to talk about could life or does life exist still on Mars now? Yeah. But largely, the surface of Mars became seemingly not a great place to look for life.
Yeah,
the surface.
Yeah.
But we'll talk about that more next week.
Yeah, definitely.
Because there are still active features and things going on, which have been observed recently. Potentially water-related features.
Yeah, like people probably saw in the news that these things, like dark streaks on hillsides that we've known about for a few years, and they kind of form, like in the summer, I think early summer, Martian summer, and then they grow, and then they gradually fade away. And people thought they were to do with liquid water, and like recent spacecraft data has shown that they probably are to do with liquid water, probably.
Yeah.
So there's a good example of something that's happening now.
Yeah.
That's it's an active process and all that stuff involving water. It just so happens that the water is involved is probably super salty.
Yeah.
And not very nice.
So if we think back then to the overall kind of overlook of Mars's geological history, there certainly were times in which it seems like it could have supported life.